Okay, so I just want to review the equilateral theorem with you all. Okay, so remember when we have the equilateral theorem, right? You're going to have a triangle with 3 equal sides. But besides knowing that, we will know that their angles will also be equal to each other. Now, with the converse, they may show you have 3 equal angles, but we would know we actually have 3 equal sides as well. So they're sort of connecting to each other. It's just sort of like opposites. So if we want to go ahead and use these two theorems in a problem, this is something they would give us, right? So we have a triangle with three equal angles, and we have to find the missing sides. But according to that converse, the converse of the equilateral triangle theorem, right? We know that all 3 sides are actually equal to each other. So you can just set up your problem like this. X is equal to 2, and that's your value, over here. That'll be 2. And this side as well will also be measured as 2 feet. Oops, I forgot the measurements. Now, let's look at a problem like this over here. Again, they showed us 3 equal angles. And again, just by that converse, we also know that those sides will also be equal to each other. So we're using the converse again. And since we know that all the sides are equal to each other, this is how we can set up our problem. 2t plus 1 is equal to 4t minus 8. So these two expressions are equal to each other. And if we want to find the value of t, we can just use inverse operations. So that crosses out, this crosses out, right? I'm getting all the t's on one side. And we would get like a positive 9 over 2. And if they ask us to find one of the sides, we can just plug in this value into either of these expressions. So let's say we decide to plug it into 2t plus 1. If I put 9 over 2 for t, notice how these two cross out. You could simplify them. You're just left with 9 plus 1, and that equals 10. So all of these sides all together, they should be 10. Their measurement should be 10. Now, let's say, for example, we know that these angles are equal and all the angles of the triangle add up to 180, but they want us to find what is the measure of one of the angles, right? And keep in mind, this applies to all equilateral triangles. Okay? So since I know one side is x, right? I could tell that all the other sides are x, right? So if I go ahead and set up this problem, and remember all the angles equal to 180, I combine like terms. You divide both sides by 3, x is equal to 60. So this is just to show you that with any equilateral triangle, you're going, all the angles inside should equal to 60. So all of these angles should be 60. That does not change. Now they might word it a little bit differently. Let's like this one over here. So we know that all the sides are equal to each other, but we're just missing one of the angles, right? If I want to go ahead and set this up using that knowledge that all the angles in an equilateral triangle is 60, I can set up the problem like this. 3x plus 15 is equal to 60, right? So then here, I'm going to go ahead and get x by itself using inverse operations. I think this is going to be 15. And let's say, for example, they want us to, well, if they were just asking for what the value of x is, it's 15. But each of these angles will be 60. So let's look at a problem like this. What would it look like if we were trying to find what the value of x is? So if we are trying to find that value of x, how would we set up that problem? Okay, so I'll give you some time to think about it. Okay. If you said this, oops, 30x is equal to 60, that would be correct. We know that all the angles of an equilateral triangle is 60 degrees, so we can just set up as 30x is equal to 60. Now, some of you might be comfortable setting it up like this. Okay, you can't see that. Like, since that one is 30x, I know all three of them are 30x, right? But you're going to do that extra work of just combining everything. So you would have to go ahead and do it like this over here. It would still give you the same answer, but you have that added step of adding everything else over here. Now, in order to find out what the answer is, you would just end up with 2. X is equal to 2. Now let's look at y, right? We want to solve for y now. Knowing what we just reviewed, right? How would we set up the problem here? And I'll give you some time to think about that. Okay. So if you said this, so you would set up as 2y plus 3 is equal to 23. That's correct, right? So remember, with equilateral triangles, all the sides are going to be equal to each other. So that means these two sides will be the same value. And if we want to find that value of y, it'll look like this over here. We used inverse operations, got y by itself, and we got y is equal to 10. Okay, so that's just a quick little review on the equilateral triangle theorem.